Welcome Science 10s to your first unit of the course. This is Unit A, and our first unit is going to be looking at chemistry. Okay, so to start this lesson, we're going to look at two ways it's commonly used to heat up food. One, stove element, and the other, a natural gas stove. And although these look pretty similar, they're both giving off heat, they're both giving off light, and they appear to be having a color change. There's something fundamentally different between both these methods of heating. The top one with the element, there's electrons flowing through there, and it's a high resistance metal. So there's kind of like some friction going on, which generates the heat. But we start with metal, we end with metal. This is just a physical change of warming up that element. Nothing's actually changing in the metal that we couldn't reverse. But in the bottom one, looking at the natural gas, we're changing the gas significantly. The natural gas that's flowing out of the oven has started to react with the oxygen in the air. It usually takes a spark or a match to start that, and it's reacting, turning into new chemicals, mostly carbon dioxide and water, maybe some other off gases, but this is a chemical reaction occurring. We can't really undo that and remake the natural gas. This is a chemical reaction, and that's a physical reaction. And that's the idea what we're going to be looking at today, the difference between physical and chemical, both properties and reactions. And it's important to know what chemical properties and physical properties things has, because we talk about chemicals now a lot more, maybe even more than we did before, for some good reason, because we're learning about some other effects of chemicals, but we want to know what chemicals we should be concerned about and which ones we shouldn't. So understanding their chemical properties is a good thing to be aware of. So that's our first lesson here, lesson 1.1, physical and chemical properties. Okay, so if we have some concern about chemicals, we should first figure out what a chemical is. And a chemical is defined as being something that is made up of protons, neutrons, and electrons. And if that's familiar at all from junior high science, you might remember that all elements and all mass is made up of protons, electrons, and neutrons. So everything is a chemical. Sometimes the word chemicals makes us think just bad stuff, but everything's a chemical. Water is a chemical, oxygen, hydrogen, nitrogen, everything's a chemical. So to determine what's good and what's bad is we have to look at those chemical and physical properties. Okay, so starting with physical properties are what a chemical is like just on its own. A chemical is like in its own state when it's not reacting with anything else. So common descriptions of physical properties is state. Is it a solid, a liquid, or a gas? What color is it? Maybe if it's got a shiny characteristic, and maybe what happens when you try and bend it. So for example, if you took glass, tried to bend it, it'll probably shatter, but metal is going to be a little bit bendable. Okay, so those are describing what it's like on its own. Chemical properties, probably a bigger focus for a chemistry lesson, is what happens when that reacts with other chemicals. If we mix these chemicals together, what's it going to do? What's going to happen? Okay, so for example, I took an acid and I mixed it with a metal. It's going to start a reaction. It's going to start to create new things. So acidic or flammable are descriptions of what would happen when it reacts with other things. Flammable when it's reacting with the oxygen and burning. Okay, so now going from properties into change. We're going to start with chemical change on that side, as that's going to be the bigger focus of the unit. It's when you start with one chemical, react it with another one, and create new chemicals. They react and form something new. Okay, what's going to happen every time you have this is there's going to be an energy change. It might get warmer, it might get colder. Most of them are getting warmer, like the example here with the stove. We take the natural gas, react with oxygen, and it releases heat. Okay, you might be thinking this one is releasing heat too, but that's going to be a physical change for this reason, that we change its physical properties, but it's still the same thing. That metal coil is metal at the start and it's metal at the end. We may have changed its temperature, but it's metal the whole time. Another example would be if you were going to boil some water. The water heats up, we heat it up, we turn it into a gas, but you can turn it right back into that liquid, and even when it's evaporated, it's still water. So same chemicals, staying the same, that's physical. Reacting, creating new ones, that's chemical change. So test questions often ask if it's a physical or chemical change, so try and give you some ways to distinguish between each of those. And I have 5 things here. The first one is gas produced. If it creates a gas, that's often a new chemical. It could be a chemical change. I say could be because that one's a little difficult, because what if you evaporate water? It's still water. That is a physical change. So gas produced is a maybe, I would say. A precipitate might be a new word for you. It means when you take a liquid and another liquid, we mix them together and it makes a solid. So both things were liquid at room temperature. We make a new chemical that's a solid. That's pretty good evidence that you made a new chemical, and that is a chemical change. Color change is often happens, but not always, so that's maybe. The last two I really like. Difficult to reverse. So think about if you were to burn a candle and it creates some gases in the air. Could you take those gases and make a candle out of them? It'd be really difficult to. That's a chemical change when you burn a candle. It can also be used to differentiate for some tough questions, maybe like cooking an egg. It might think, well, I just warmed it up, but we've changed some of those proteins in there that I can't really reverse it. It's hard to uncook an egg. When you heat an egg up, it actually undergoes some chemical changes inside of the egg. So that's a good one to help you determine between the two. And the last one I underlined here, that this must happen in a chemical change. It must increase or decrease its energy. You talk more about this later on in courses like Chem 20, but each chemical has a certain amount of energy to it. When you make new ones, it's going to have more or less, so energy is going to be released or absorbed. That's the one thing that has to happen in every chemical change. All right, so to finish off this lesson, we're going to talk about some chemical safety. But the first question says, why should you be cautious around some chemicals? And there's really three answers. Three answers is the first one, we know an energy change has to occur when they react, and that potentially could harm you. If it releases a lot of energy and explodes or lights on fire, you're not going to want to be around that, so that could cause some damage to a person. The second one is a chemical could disrupt your body function. You're undergoing chemical reactions like cellular respiration that are good. These are helped to keep you alive. And if something interrupts that, for example, carbon monoxide messes up with your ability to take in oxygen, it's going to change your body's function in a bad way. So we don't want it to disrupt our normal body functions. And the last one is if it's a very reactive chemical, and everything's made with chemicals, you're made of chemicals, we don't want it to react with you, because a chemical reaction is when we turn some chemicals into new ones. We don't want to change you into any other chemicals, so want to stay away from those things that would react with you, like your skin, things that are corrosive and things like that. So how to become aware of chemicals that could be harmful? WHMIS is a workplace hazardous materials information system, as it says there in the notes, that is designed to make it so we have consistent or standard information, labeling, training, procedures for all chemicals. So it's not different from one job to another. They have the same symbols, and that's mostly what we're going to go through. You probably get this training at any job, but in case you're a bit unfamiliar, we'll go through these symbols and see what they mean. So on the screen, it shows a long description of each one, and it's definitely good to read that in full to make a good understanding of what they mean. But I'm going to sum them up with just a couple words. So the one at the top left, that one represents flammable, just means it's easily ignited or burned. The next one that looks like flammable, but it's got an O, that one's oxidizing, which means it's just basically very reactive, reacts with oxygen quite quickly. The next one is compressed gas. This is a danger because if you heat it up or damage the container, it could explode. Next one being corrosive. This is the one that we don't want to react with you, so it could react with your skin. We want to avoid that. And the last one there, explosive. Heat or damage could cause an explosion. Those ones typically students are familiar with or kind of heard of. The next three are probably the most difficult. The skull and crossbones, kind of the explosion from the chest there, and the exclamation mark. They're all potentially toxic, but different levels. The worst one at the top there is acute toxicity. It says severe, immediate risk, even in small amounts. So it can cause problems really quickly that are quite severe. Health hazards, the next one, which says disrupts body function. Examples of cancer and lung damage they're bad things, but they might not happen immediately. They might take some time. And the last one there is hazardous. It's a little bit less severe. It's a mild health risk. Maybe you'll get a rash, maybe you'll get a bit of a burn or an irritation, but not as bad as the other two that could be potentially fatal. And the last two here are also usually pretty familiar for students, but let's go through those. This one, biohazardous, could give you a disease, so maybe there's some sort of bacteria or virus would get one of these labels. And the last one, environmental hazard, which appropriately shown with the square, a dead tree and a dead fish, it could harm the environment. So those WHMIS symbols are good information, but sometimes we want a little bit more information about the chemicals. And if you were to order one, say through work, you might get one of these sheets, which is an MSDS sheet. It just gives lots more information about how we should store it, what chemical properties, what happens if you have a spill, so emergency procedures, hazards, and all that kind of thing. You never have to memorize one for this course, but you need to know that if I give you one, you can look up some things, like what happens when you spill it, what happens when it gets in the eye, where should you store it, and things like that. Okay, so those often come in the workplace when you order chemicals. But the one that's probably more applicable to everyone, say maybe you don't have a job where you work with chemicals, is household hazardous product symbols. These ones you're going to see on cleaning materials and things that you would just have around your house, maybe paints or paint thinners, things like that. So they're probably more important because everyone's going to interact with these, and fortunately there's fewer of them to remember. So poisonous, flammable, explosive, and corrosive, and kind of self-explanatory based off the pictures, but there's also some levels for how harmful they would be. So if it's got the octagon around it, that's a pretty serious one. That means it's quite dangerous. If it's got the diamond there, just warning, and if it's got the triangle, it's caution. Now, not saying that these aren't bad, there's just different levels of how severe these things would be. And that's it for our first lesson. Hopefully that helped you out with the difference between chemical and physical properties and chemical and physical change. Thank you so much for watching, and I'll see you in the next lesson.